The next part of our module is inductive proximity sensor. In the previous class, we have seen the basic proximity sensor and eddy current proximity sensor working principle. The difference between the eddy current proximity sensor and inductive proximity sensor is same. Diagram wise it is going to be same. Here we are having an amplitude or detecting circuit, oscillating circuit, output circuit. Here we have an oscillating circuit, signal evaluating circuit and switching amplifier circuit. The eddy current proximity sensor is meant for detecting the non-metallic object, but it has to be a conducting material. Whereas the inductive proximity sensor, it is mainly used for detecting the metallic object. So it is the figure that shows your inductive proximity sensor. It has got 4 components. One is your component, another one is your coil, oscillator, deduction circuit and the output circuit. So when you are applying a alternating current to the coil, it generates one magnetic field. When the object or the material is made to get closer through this magnetic field, the inductance of the coil will get changed because L is equal to N phi divided by I. So when your flux is getting disturbed, your inductance will also get changed. So this is continuously monitored by your circuit and it triggers to switch the preset value of the inductance changes occurred. So this is how your proximity sensor, inductive proximity sensor senses the object. Next application of your inductive proximity sensor is industrial automation, that is for counting the number of product during the production or transfer of a product or transferring a product. Security purpose, detection of metal objects, arms, landmines, etc. Next we have a capacitive proximity sensor. So inductive proximity sensor inductive proximity sensor uses magnetic field to detect the object, whereas the capacitive proximity sensor uses electric field. Now we will see one type of capacitive proximity sensor. Here the capacitive proximity sensor, it is used for non-contact detection of metallic object. Without any physical contact, if your metallic object or your non-metallic object is going to be detected, then it is done with the use of your capacitive proximity sensor. Capacitive proximity sensor output will show it as a variation of a capacitance when the object is being detected. So when the object is present from a sensitive side of a sensor, electric circuit. So here depending upon the distance, you have a oscillating circuit, DC supply circuit. So the capacitive proximity sensor senses both metallic object as well as your non-metallic object without any physical contact. Normally the object is sensed with by understanding the variation in the capacitance at the output. So the variation of capacitance between the sensor and the object detected is nothing but your capacitive proximity sensor. In this, whenever your object is present, you consider when an object is present, the distance from the sensitive side of the sensor and the electronic circuit inside the sensor will tends to oscillate. So whenever the object is present, the sensitive, you have two sides, one is your sensitive side and another side is your effective capacitor plate in the target. So the sensitive side of your capacitor plate will begins to oscillate. So this oscillation is identified by your threshold circuit and it is amplified for the operation of your external load. A screw will be placed at the back side of the sensor just to maintain the regulation and the operating distance. The sensitivity regulation is useful in applications such as deduction of full containers and non-deduction of empty containers. The operating distance of the sensor depends on the actuator shape and size and it is strictly linked to the nature of the material. So capacitive proximity sensor is a sensor which detects both metallic as well as your non-metallic object without any physical contact. The variation in the capacitance between the sensor and the object being detected is recorded whenever the object is present. Whenever the object is present, the sensitive side of your sensor makes the internal built electronic circuit to oscillate. This oscillation is identified by the threshold circuit and that particular voltage is being amplified and whenever the object is detected, the sensitive part will tries to oscillate the circuit, and it is measured by the threshold circuit. The threshold circuit is then supplied to the drives the amplifying circuit for the operation of your external load. And some of the applications of this capacitive sensor is for detecting your non-detection of your empty containers. This is how your proximity sensor works. The next part of your module is pneumatic sensor. Next is your pneumatic sensor. Pneumatic sensor is mainly meant for measuring your displacement. So displacement, in the sense, we have even resistive transducers, capacitive transducer, inductive transducer for the measurement of displacement. Here it can measure the displacement from fraction of mm to about 3 to 12 mm, as well as to sense the proximity of an object closer to it. So here the distance and proximity are transformed into change in air pressure. Here we have shown a figure. It has got 3 ports, port A, port B and port C. Port A is mainly meant for low pressure air inlet. Here whenever the object is identified, low pressure is allowed to pass through this port A. Whenever the object is identified, that time the object abstracts this low pressure. At that moment, the pressure in port B will get increased. Suppose if there is no object, then it will allow the low pressure to blow through this port A, and eventually the pressure at port B will also get reduced. So when your object is present, whenever an object abstracts this low pressure, that time your pressure at port B will get raised. There will be a rise in pressure at port B. So air is getting dragged out of port and so drop in system pressure. This is how your pneumatic sensor will work. This type of sensor is mainly used in robotics, pneumatics and for tooling in CNC machine. When there is no material, the low pressure whatever you are blowing here, it just passes through it. Okay. You consider you are having a metallic object or non-metallic object, anything you are having over here. So when you are passing a low pressure through this air inlet in port A, it tries to escape here and it starts to blow. It is also port A. It is also similar to your port A. So it tries to escape outside. When it is going, when your low pressure air is allowed to escape outside, and when any objects are present in front of this escaping air, then when this object is very close, what will happen? This air flow will strike out and it starts to increase the pressure on the other port. This is how your pneumatic transducer works to identify the distance. So this escaping air, in the absence of any close objects, escapes, and in doing so as to reduce the pressure in the nearby sensor. Here the pressure will get reduced, whereas the pressure in port B will get increased. However, if there is a close by objects, the air cannot so readily escapes and results in pressure increase in the sensor output port. So it is your pneumatic transducer.